So this is a rational inequality. For solving these sorts of inequalities, the first thing I want you to do is make sure that you have 0 on one side. So I'm not going to stipulate whether it's the left or the right, but make sure you have 0 on one of your sides. And then the second thing you want to make sure that you do is you want to make sure you have a single fraction on the other side. Okay. Don't start steps 3 and 4 until you've got that. The third thing I want to do, if it were just a polynomial or quadratic, I would find the zeros. But I'm going to find the zeros, and in this case, the vertical asymptote of the non-zero side. So remember that zeros, real zeros of a function, are also known as the x-intercepts. If you have the function y equals x minus 3 over x plus 7, for a rational function, the shortcut is that I only have to set the numerator equal to 0. And so if I set the numerator equal to 0, I know that x equals 3 is going to be my x-intercept for that graph. And then we know that we set the denominator equal to 0 to find the vertical asymptotes. And so I'm emphasizing what these things are graphically because it's going to affect the use of brackets versus parentheses. So I go ahead and solve that and get x equals -7. So that's my vertical asymptote. And so now my next step, I think I had made that step 3. So my fourth step is going to be to make a number line. Make sure you put your numbers in there in order. And then I'm going to test my intervals. So I'm going to pick a representative from each interval. Let's see, -10 is smaller than -7. I like to use 0 when I can. I'll pick 5 here. Just pick any number in each of those intervals. And so then I'm going to plug it in to the non-zero part of my inequality. So I'll write more work out for the first one, and then I'm going to write less work as I go. So if I plug -10 into the left side there, I get -10 minus 3 on the top. I have -10 plus 7 on the bottom. So I get -13 over -3. But the only thing I care about is that the answer is positive. And so I know that I'm going to get a positive y value. So if I plug any number smaller than -7 into that fraction, my answer will always be positive. So same thing, except I'm going to condense my notation. 0 minus 3 will be negative, and 0 plus 7 will be positive. And a negative divided by a positive is a negative. And so on this interval, no matter what x value I plug in, the answer to the fraction will always be negative. And then at 5, if I plug 5 minus 3, I get a positive. 5 plus 7 is positive. And so a positive divided by positive is a positive. So I remember that if I have less than 0, that's the same as saying negative. So I know that I'm going to pick my middle interval. So now I need to worry about my endpoints. So I'm going to remind myself that x equals -7 was a vertical asymptote. Sometimes it's handy just to kind of put a dotted line through there to remind myself that that was a vertical asymptote. If I would plug -7 into that thing, x equals -7, plug it into the fraction, I get -7 minus 3 over -7 plus 7. So I get -10 over 0. Okay, if I'm trying to say that is less than or equal to 0, is that true or not? Is -10 divided by 0 less than 0? Or is it equal to 0? So -10 divided by 0 is undefined, and undefined, I can't say that something undefined is less than 0. -7 does not work. If I plug in x equals 3, I get 3 minus 3 over 3 plus 7. I get 0 over 10. And so it's okay to say that that is less than or equal to 0 because 0 divided by 10 is 0. So that one works. 3 works, 7 does not work. So I have to put an open point at -7, closed point at 3, and I'm keeping the numbers in between. In interval notation, you would use parenthesis -7, comma 3 with a bracket. So again, I said that there is an x-intercept at 3, and so you can see that here on the graph. There was a vertical asymptote at -7, so this is just Desmos if anyone's used it. You can see that the vertical asymptote is at -7. And so remember that we were trying to find out when is y less than or equal to 0. The y values are smaller than 0 when the graph is below the x-axis. So I'm looking at this part of the graph, but the word solve tells us that I am finding the x values. So I'm finding the x values that cause that to happen. So -7 itself does not work, but the numbers really close to -7 work, infinitely close. All the way up through 3 does work. So again, my solution to that inequality is going to be parenthesis -7, comma 3 bracket.